My name is Marco Romani, and I will be presenting the Cognitive Adaptation and Mission Optimization, or CAMO system. I'm a retired U.S. Navy captain. My last assignment prior to retiring was as the MQ-25 Stingray Requirements Officer at OpNav N98. Opto-Knowledge was founded 30 years ago by Nahum Gott, an aerospace PhD and former TRW employee. While at TRW, he was in the Combustion Research Group, where he worked on airbag inflators and other projects. In his younger days, he was also a member of the Israeli Defense Force and saw combat in the 1967 war, the War of Attrition, and the 1973 Yom Kippur War as a tank commander. Dr. Gatt founded Opto-Knowledge to apply the then nascent technology of artificial intelligence to applications using hyperspectral images. Since 1991, Opto-Knowledge has moved into multiple other disciplines. Opto-Knowledge has been recognized multiple times for excellence in R&D and commercialization. Our customers include the Missile Defense Agency, the U.S. Navy, the U.S. Air Force, the U.S. Army, the intelligence community, NASA, the Department of Energy, NOAA, and many commercial companies. Our sales are currently approximately $12.5 million per year. And Opto-Knowledge's operational mode is we look for funding R&D from government and industry to support U.S. government science and technology programs. We develop prototypes for concept demonstration, and we license our technology. Opto-Knowledge is a multidisciplinary systems engineering company specializing in EO, IR remote sensing applications, complete systems or subsystems, including phenomenology, software, hardware, developing algorithms, and real-time processing. Our sensors range across the UV through the LWIR. We design and build multispectral and hyperspectral imagers, spectrometers, and other devices that can be used in situational awareness, data gathering, and targeting applications. We have developed ground and air autonomous systems using deep learning machine vision techniques for GPS-denied navigation, ATD, ATR, and sense and avoid techniques. We also work with mid-IR lasers and absorption spectroscopy and have developed proprietary hollow-core fiber optic waveguides. Our work and products have been used in ground, air, sea, and space applications. CAMO leverages much of our prior work to provide a capability to allow multiple dissimilar unmanned vehicles to team and perform complex missions autonomously. The Navy Challenge. Currently, missions involving multiple unmanned platforms require a great deal of human operator burden to optimize search areas that show the most promise for finding targets of interest while minimizing risk exposure to the platform. The demands on unmanned vehicle operators is increasing as the capabilities of unmanned vehicles increase. Finding mobile targets is complicated even with a single platform, but when multiple dissimilar platforms are involved, divvying up a large search area can become intractable for human operators. CAMO will allow operators to focus on executing complex tasks and mission success by not having to focus on low-level control issues. To truly meet the potential of unmanned systems to lower operator workload and lower the number of required operators, unmanned vehicles must become more autonomous when completing complex missions. One operator should be able to manage multiple unmanned vehicles. Opto-Knowledge developed the Cognitive Adaptation and Mission Optimization, or CAMO system, in response to the Navy need. The Common Control System, or CCS, is the transition target for CAMO. CAMO embedded within CCS will ultimately allow one operator to manage multiple dissimilar unmanned vehicles. CAMO and CCS will lower the number of operators needed to perform complex missions. CAMO will allow the teaming of dissimilar unmanned vehicles across domains. We believe CAMO incorporated into CCS Increment 3 would accelerate the Increment 3 goals of including cross-domain capabilities and control of multiple dissimilar unmanned vehicles into CCS, and should help enable the United States Navy Unmanned Campaign Plan. Developed with the help of Washington State University, CAMO is an artificial intelligence-based approach that mines action-based intelligence, or ABI data, to leverage domain knowledge. For example, the probability and uncertainty maps are generated from ABI data, which includes target knowledge, such as known behavioral patterns, dynamic constraints, and unmanned vehicle dynamics, and sensing capabilities, to optimize the probability of finding targets of interest. For CAMO, the STTR objective was to localize and identify wild horses on training ranges with unmanned aerial vehicles and have the unmanned aerial vehicles and unmanned ground vehicles autonomously team to corral the horses. CAMO can be modified for any moving target. By leveraging machine learning and artificial intelligence, or deep learning, CAMO will enable UAV-UGV coordination to complete complex mission objectives. CAMO has 5 pillars. The first pillar is the ingestion of aeronautical reconnaissance coverage geographical information system, or ArcGIS data. The second pillar, generating the probability maps of where the targets of interest may be located, will be determined by action-based intelligence and pattern of life data, such as weather, time of year, vegetation, terrain, vehicle capability, and other applicable data. The human operator is able to use their expertise by dynamically changing the weighting of the inputs if desired. The third pillar is the probability maps are then used to develop machine learning-based route planning. The fourth pillar consists of the Opto-Knowledge developed automatic target detection and recognition techniques used to analyze the sensor data. The fifth and last pillar, as the search area is covered, the process is updated in a feedback loop using Bayesian updates to modify the probability maps. CAMO effectively has the ability to think ahead using prior findings. OptoKnowledge believes CAMO will tighten the maritime OODA loop across domains. Currently, most unmanned vehicles require multiple crew to operate the platform, manage the sensors, and analyze the sensor data, and then determine the next step in the mission. The vehicles are not really unmanned, they are unoccupied. Using CAMO, OptoKnowledge believes the U.S. Navy and other services can reach a goal of having 1 or 2 operators manage multiple autonomous systems performing complex missions across domains. Ultimately, CAMO will enable a tightening of the OODA loop. CAMO in real-world scenarios should be able to improve autonomous maritime ISR, contribute to planning maritime strikes, enable cooperative weapon engagement where long-range autonomous weapons can engage high-value targets, and optimize weapon-to-target pairing. CAMO successfully completed multiple UAV flight demo at Yuma Proving Ground during the week of 13 July 2020. CAMO STTR Phase 2 option was funded the week of 20 July 2020. The current TRL is at Level 6. The OptoKnowledge CAMO program has successfully demonstrated the ability to leverage machine learning and artificial intelligence, or deep learning, to enable unmanned aerial vehicles and unmanned ground vehicle coordination to complete complex mission objectives. CAMO embedded within CCS will allow dissimilar unmanned systems across domains to team and perform complex missions where the operator can focus on a high-level mission task instead of monitoring low-level tasks. Operator input can be real-time while mission is being performed. CAMO will enable lower manpower and training costs by having fewer operators and mission analysts. Operators will potentially not need to be trained as vehicle operators, but instead can be trained as mission commanders. CAMO will be unmanned maritime autonomy architecture compliant. CAMO needs a real-world application to progress into a system where the warfighter can take advantage of the CAMO capabilities. Candidates could be Triton teaming with other class unmanned aerial vehicles or unmanned surface vehicles, possibly as a microservice for the Joint Mission Planning System follow-on. The CAMO transition advocates are within NAVIAR. Alternatives outside the United States Navy could be the United States Air Force Skyborg or Loyal Wingman projects, foreign military sales to NATO through the Maritime Unmanned Systems Innovation and Coordination Cell. DHS Border Security could use pattern of life data to find routes used by both human traffickers and drug smugglers. For the Coast Guard, anti-drug smuggling, and also in wildfire detection and fighting. To successfully transition CAMO from Phase 2 to Phase 3, OptoKnowledge needs introductions to the decision makers that can provide the authorization and funding approvals to go to the next stage of development. OptoKnowledge is looking for the right partner to bring CAMO to the warfighter. CAMO will enable true autonomy for the United States Navy across all unmanned vehicles, resulting in lower manpower costs, increased capabilities, and the enabling of the U.S. Navy to be at the leading edge of autonomy. Please feel free to contact Dr. Holmes Parker or myself for more information on CAMO.